very detailed presentation to you because this is a $1 million warrant article. And so we wanted to make sure that you had all of your questions answered before we got to town meeting. So this evening we have Joe Ducharme, who's been the primary engineer on the planning for this project, working for Hoyle Tanner, and Rob Burho is our chief operator for the water system, and our other license here in town is Jim Mayhew. So we got both of our licensees and we got our engineer. We should be able to answer any of your questions. I'll have a concern if they can answer.
Well, if we can't, we'll get back.
And we'll get back to you if we can't answer the question this evening. So I'm going to turn it over to Joe.
Thank you, Mark. Thanks, everybody. So as Mark said, I've been involved in some of the planning, and I've been with Hoyle Tanner Associates about 2 years prior to that with CMA Engineers, and we did some of the other water system improvements over the last 10 or 12 years. And this particular project is the last piece of the water supply and treatment portion of work for the town. And what I'll do is, let's see, there we go. So for tonight, what I thought I'd do is just kind of give you an overview of the system. Some of you may be more familiar than others with the water system here. Talk a little bit about the history of the wells that the town has had in use for years. Talk a little bit about some regulatory changes, and that's not necessarily today's changes. It's over the life of the system. Some of the more recent improvements that the town has done. The town's made an investment in the water system over the last 15 to 18 years to make it more sustainable, more resilient, and protect the supply for the town. And then some of these project goals, what are kind of the driving factors of doing this project now. What we're calling the recommended project. We looked at several alternatives, and I'll review some of the alternatives we considered as well. The project budget just breaks down the construction costs, engineering, permitting, and then how does the town fund the project. So the water system in Waterville Valley. This is a little clip of a map more on the north end of the community. West Branch Road is here. The bridge is here. This is River Road, the switching station. And this goes over into Triple I Road here. So you'll see the main branch of the Mad River and then the west branch over here. The system originally had well number 1 here, well number 3 here, well number 2 here. There was a 4th well added in 2016 or so. I think it was brought online 2016, 2017. But essentially right now, the town is working with 2 active supply wells, 2 storage tanks. The storage tanks are, whoops, sorry about that. Storage tanks are here on Snows Mountain. So what you'll notice is well 3, well 2, well 4 are all on the west side of the Mad River. The tanks are over on the east side. There's one pipe that connects all the wells, the supply, to the tanks and the bulk of the distribution system. There's obviously more of the distribution system to the south. There's about 7.5 miles of water mains under roadways in town. There's about another 2.5 miles of cross-country mains. Those are mains that go up Snows Mountain, that connect well 4 down to this area, to the new treatment building, and mains such as this from well 3 that don't have any service connections to them. There are about 1,224 connections in town. There are water meters now on virtually every connection, I think. There are 2 well buildings, well house 1, well house 2, and then there's a centralized treatment building that was put in next to well house 2 about 3 or 4 years ago. This is just a blow-up of that map as well. And what I wanted to point out here, the rules over time have changed. These are what they call the sanitary radius around the well. Each drinking water well in New Hampshire now is regulated to have a protective sanitary radius. If you were to try to put these wells in today, well 3 could go in. Well 1 touches on some development. Well 2 probably wouldn't be allowed because there are homes there. One of the projects that the town did some years ago was to actually put a low pressure sewer in, and that was to meet some regulatory requirements for collecting wastewater and not having any potential for contamination from the septic systems getting into the well. There's also something called a wellhead protection radius. These radii here, it's 400 feet. I think this one's a little less because well 1 is a lower producing well. So 400 feet, 400 feet, 400 feet for sanitary protection. The actual wellhead protection can be anywhere from 1,500 to 2,000 to 2,500 feet, depending on the flow rate of the well. So if you were to expand this out to the wellhead protection area, you're encompassing a lot of existing development. So that's important to note from a treatment and sustainability
Can you
perspective.
tell us which wells we're using right now?
Right now, you're using well 2, which is right here, and well 4 up here. Okay, and I'll actually, I'll get it, that's a good question. I've got another slide here that'll give a little history as well. So, over the years, when well 1 went in 1968, that was a lower producing well, 85 gallons a minute, but that's, as the town was being planned and developed, that was adequate supply. There was a storage tank that was added on Snows Mountain. I don't have the exact time frame for that, so I could estimate it around 1970. I believe it was between well 1 and well 2. As the town was planned and continued to develop, they realized they needed more water. They did a bunch of exploration. Well 2 was put in 1972. That's a much higher producing well, 280 gallons a minute. Well 3 went in 1984. That ended up, I think that was originally permitted for 200 gallons a minute, but has produced historically about 150 to 180 gallons a minute. In 2004, another storage tank was added, and part of that was to create some additional supply for fire suppression and sustainability, but also because the original tank went back to 1970. So at that point, 34 years old now, closing in on what, 40, some odd 50, almost close to 50 years old.
So tank 2 is on Snows Mountain as well?
Yes, it's right, actually, Bill, it went in right next to tank 1.
Okay.
And the reason for that was that was really the highest elevation to provide as much gravity flow to the system. So putting it at the same spot, it's what we call a hydraulic gradient, provided the same hydraulic gradient as tank 1.
What's the capacity of the 2 tanks?
The nominal capacity is about 1 million gallons, or about 500,000 gallons each, but operating capacity is less because there's spill and draw from the tank. So there's always some head space that's not used in the tanks, and always some storage at the lower level. If that storage, I think from operating bandwidth, you're running anywhere. I looked at some of the records you sent me, and some of the peak days are consuming 300 to 400,000 gallons a day. So the tanks supply that easily, but the total capacity is about 800 to 800,000 to a million. There's always space there's always water that doesn't get used out of that.
Is there a lifespan on storage tank 1?
There is, I would say yes. When the tank, each I think every 3 years now, every 5 years, the tanks are inspected. And the original tank had a kind of a precast panel roof system put in with a concrete slab cast over it. That is probably not as strong as the tank that was put in 2004. But through the regulations and through the town's cooperation, it's inspected every 5 years and monitored. So there may be a point down the road in the future where that tank 1, there might need to be a rehabilitation of that tank 1. Right now, from the reports I've seen, the inside of the tank is clean. There's no sediment accumulation. Structurally, it appears to be okay. But it's something to pay attention to.
So you said our daily usage is 300 to 400?
It varies.
But within it?
There can be days, I've seen days where it's 100,000 gallons a day. If you think about the population here and fluctuations for Christmas week, Thanksgiving, coming up is going to be the Massachusetts School Vacation Week. That's going to be a big use time. That might be a 300 to 400,000 gallon day period.
Basically, what 2 and 4 can handle daily use.
They can handle daily use, and what happens is when one of those wells is out of service, you always have to be able to meet those demands.
Yeah.
And that was the rationale for putting well 4 in. And since well 4 went in, well 3 had a bacteria contamination issue and was taken offline. After that was taken offline, there was also a period where well 2 pump went down. So the town was operating on 1 well. So the system, there should be redundancy in the system.
Yep.
And so there are reasons to bring well 3 back into the system for that redundancy. And you want it because if you need to take a well down to service the pump, replace the pump, you have to have that capacity.
Yeah, Joe, what does DES say about how much we're supposed to be able to, this is another one of those 1,000-year flood things, I know.
So far as capacity goes?
Yeah.
Yeah. So the rule as it's written says you should be able to meet your average day demand with your largest well out of service. So if the average day demand in April is 120,000 gallons a day, you've got it. If you look at the average day demand during the Christmas week or the mass school vacation week, then you start to hit the margins where 1 well isn't enough. So again, that's a rationale for bringing well 3 back into the system so that you have that redundancy in the supply. And this
So
chart
is there no definition of what average days demand is?
well, as I say, because you're a resort community, Bill, and you have,
Right. But from the state's perspective, they don't define how you should calculate that.
well, they're,
Or do they?
yeah, they do, and the thing is, for one of the rule changes that affected the town some years ago was because of the larger fluctuations in population, because it's a resort community, Waterville Valley shifted from a small community water supply to a large community water supply, so they fell under the large community water supply rules. That had an impact on the town having to put together a water conservation plan, having to install water meters to bring a new well up. So there were a lot of rules that affected the town falling under this larger supply, groundwater supply rule, that when DS looked at it, they said, well, you need capacity to serve 4,000 people, whether 4,000 people live there year-round. So they look at those higher flows, that pushed the town into the large community water supply rules, and they look at those higher flows as well, factoring into that. This chart here, didn't intend for anybody to read that. That was actually just a summary of all the test wells that have been done in town over the years. And the point really there is the wells that you have are probably the wells that you'll only ever have. There's been so many exploration wells done up and down the Mad River, the White Mountain National Forest, town property. So again, preserving what you have is a good idea. I mentioned the regulatory changes in Bill, the small system rules, that was what the town fell under years ago when those first 3 wells were put in. And then during probably 2009, 10, 11, when the town was looking to make other improvements in the water system, DES reevaluated the service population and said, no, the town really falls under the large system rules. That brought in other constraints and requirements. The lead and copper rule, other metals, originally groundwater supplies were just disinfected. Just put some chlorine in to kill any potential bacteria and leave some residual in the system to make sure that the distribution system didn't grow any bacteria in it. Over time, lead and copper became an issue, other metals that are tested for. Robbie, you know better than me what all your quarterly source tests are. There's a lot of different parameters that are tested for now just because of the changes in the rules that weren't tested for originally. This 4-log virus inactivation, this really is making sure that there's sufficient contact time with your primary disinfectant before that water gets into the distribution system. It's not a new phrase. Bacteria, just for reference, when you use chlorine for drinking water or any other disinfectant, the bacteria usually gets killed off very quickly. Viruses are slower to respond and die off. So this comes down to a contact time calculation based based on the flow rate from the well, how much contact time you need to ensure that you're killing bacteria and viruses before it gets in the distribution system. The original wells weren't designed for that. There was no contact tank. There was just some chlorine added, and it was put into the system. So the town did some improvements in the last 10 years to resolve that. The other thing, these are recent. Disinfection byproducts they are related to chlorine reacting with organic compounds. Waterville Valley is fortunate to have 3 very good drinking water, groundwater supply wells. The organics usually come from surface waters. You're not using surface water for your source. If you've heard anything about the perfluorinated compounds, Robbie, are you testing for that?
Yeah, tested the fourth quarter and then tested the first quarter.
Have you got any results yet?
Fourth quarter was low detect, non-detect.
Right. So that would be expected. Those are compounds from manufacturing processes that wouldn't be expected here to be in the groundwater. But what that did with these recent chemicals, the state set some what they call maximum contaminant levels for those compounds. That's affecting groundwater regulations as well. Now they have whatever they set for a surface water standard now affects the groundwater quality standard. There's also going to be some rules for surface water, for stormwater on this. Fortunately, there really are no known sources for that in Waterville Valley. So the supplies you have are very, very clean, and that's very good. I mentioned some of the improvements that the town has made, and I'm going to pick it up kind of from that 2000 timeframe forward. Those are improvements that were affected by a different set of rules or more stringent rules. The water storage tank was put in around 2003, 2004, so that added some supply. That was also part of a study done by another engineer that looked at the demand and those fluctuations built in demand for, if you looked at the history of the valley, 60s and 70s, the peak usage was always winter, and it's expected to fall off in April, May, when the ski season ends. And summertime use was always very low historically. Well, now the summertime peaks and the wintertime peaks are very similar. So that demand is now more sustained than it used to be. So that study suggested another storage tank, which also, as I mentioned, helps with fire suppression. 2003 to 2008, also based on that study that was driving the extra tank capacity, began a search for another well. That study went on for several years. There was a lot of testing in addition to what I showed you before, that chart of all those different tests. There were other test wells drilled, and the Emory Garrett Groundwater was the company that did the hydrogeological study, and they found a viable well, which is on the White Mountain National Forest property. That also took some time to permit. The town has a special use permit for that well. The good news is that well meets all the requirements for protection. Sanitary radius, wellhead protection, it's land that's never going to be developed. And it's an excellent water quality as well. Also kind of paralleling some of these projects were some water and sewer improvements that were done on Boulder Path Road and West Branch Road. Some of those were to improve what was already there. Some were new sewers to tie in some homes that were on septic systems. And then in the 2012 to 2017 period, after this well was permitted, then there was a project to actually drill the well, put the pump in, run power out, bring a transmission main down to the well 2 area, put in some low pressure sewers on West Branch Road and River Road, again, to remove potential contamination sources for the well 2. There was a treatment building put in, and that treatment building was also installed with chemical treatment and a clear well. And that was anticipating not only the rule changes that we've seen in the last 10 years, but potential future changes to the rules that would require more treatment. So that building has the capacity to treat all of the town's wells.
What is a clear well?
Clear wells after the water is pumped from the wells and chemical addition happens for chlorine and pH control. It sits in a tank basically before it gets into the system. So it's treated or conditioned water that's ready for use. but it's held there for that contact time I mentioned earlier to make sure that you get the bacteria and virus killed, and then it's pumped into the system.
Joe, how long is it held, and how big is that clear well?
Good question. The clear well tank is about 30,000 gallons, and it just depends on the operation. Even if water's being pumped in and water's being pumped out, the rate change provides the contact time. I don't have the calculations in my head, I'm sorry. But it was sized so that it could be operated so that water could come in conditioned, water could be pulled out from the tank that's conditioned as well. I don't remember the numbers, sorry. I could have put a slide together, I didn't think to do that. But it was designed to be able to do that, be able to take that flow in, add the chemicals, take the flow in, the residence time in the clear well. It can only be drawn out at a certain rate, and it mixes with water that's already been in there. So that provides the adequate, and there is a baffle in the tank as well, so it gets that residence time before it's pumped out. The water conservation plan was a result of bringing the new well online. The water meters were a result of the water conservation plan, all again following those rules. And then somewhere, I think around 2016, along this timeline here, and Robbie and Jim, you could probably correct me, there was somewhere around 2016 when there was a bacteria hit in well 3.
2016, I believe it's October.
October.
You probably know the date, right? When you got the call. So well 3 was taken offline. So there was a time when well 2, well 3, and well 4 were running together. They were all being treated independently, I should add. Well 4 was the only well that was pumped directly into this new treatment building and clear well tank. Well 2 has its own chemical conditioning, and that's pumped into the piping as it comes out of well 2. And well 3 was conditioned at well building 1, but that only had disinfection. It only had chlorine. It didn't have any pH or corrosion control. So with well 3 offline, the town was back to 2 wells. And depending on which day you pick, Bill, average daily flow in April is different than average daily flow a week from now. Town was down to 2 wells. There was a period when the well 2 pump burned out, and the town was down to just 1 well, running 23, 24 hours a day, which is not a good position to be in, because if that pump failed, there'd be no supply. So.
And also, building number 1 got struck by lightning.
That happened last year?
Last summer.
Last summer.
Yeah. Or 2 summers. 2 summers.
Okay. So when well 3 went down, there was a series of investigations done, thinking originally that maybe the chemical feed wasn't working properly. So Robbie and Jim went through a systematic approach of kind of process of elimination of what might be causing that to happen. And ultimately, what was learned from that, again with irrigated groundwater, was that the construction of the well, it's called a radial well, the construction of the well was likely affecting infiltration, whether it was from groundwater or from the surface through the ground, or from some of the test wells or monitoring wells. There were monitoring wells that were put in around all the wells at one time. But ultimately they rehabilitated, regraded, rehabilitated the well, and I believe it's been tested again now, internally, in-house testing. So the state will require testing to be done to prove that it.
Joe, you might want to back up that we've tested for a while in-house, correct?
We had tested for quite a while, but then I think I tested the last 4 months just for.
Yeah, so it's not like we're going on a hunch if it's worked once.
Right, yeah.
Before we
Good point,
get
Mike.
out.
Yeah, there's been periodic testing. There have been improvements made. We did actually CCTV did some video inspection of the inside of the pipe that goes from well 3 up toward the well 1 building. That pipe looks brand new on the inside. There were no cracks and obvious leaks or anything. We did pressure tests on that pipe as well to make sure that the joints were sound. That came back perfectly fine. So again, through a process of elimination, Robbie and Jim would do some testing, then they'd flush the well, then they'd chlorinate the well, then they'd take a sample, and it's been, you're right, Mike, it's been a period of tests over a couple of years to check that. And then the work that Emery and Garrett did has improved the conditions around the well and the well construction itself.
What's the result of the testing? Good, yes, lousy, what?
Actually, I was testing for what, talked to Mark when we tested the last 4 months of the year, and the test results were coming back good. There was no E.
No E. coli. Minimal total form.
Very minimal.
Okay.
Yeah.
So it was a huge improvement.
Oh, huge,
Oh, yeah.
huge improvement.
We wouldn't be offering this alternative if we didn't have a faith that the well is working.
Yep.
What was the source for the E. coli? Is it decaying vegetable matter? What causes that?
That's E.
Nobody
coli.
could tell us exactly what it
It
was.
could have been people walking dogs out there, it could have been a dead
Could be a whole
raccoon,
bunch of
a
things.
E.
squirrel.
coli is generally generated from humans, mammals, warm blood, rather than plant matter.
If you've noticed,
Animal waste?
It could be animal
Yeah.
waste.
if you've
Again,
noticed
it's a-
out there, we had a radial well, where the concern was that people were, the dog path was close to the top of it. So one of the things, what's it, Emery and Garrett?
Yep.
Yeah, Emery and Garrett came in, they sealed the top of the well. We also had a bunch of exploration pits and holes that were out in that well area that had never been sealed before. So it was, groundwater was coming directly in there without getting down through any filtration system to it. So that's what we spent, how much did we spend on that? About 100?
75,000.
Right, we spent about $75,000 on this well to make sure that we weren't going to have, well, to the best of our knowledge and best of our experience, we're not going to have these experiences with getting E. coli in again.
And we put a fence around it to keep people away from it.
Keep the dogs in.
Keep the dogs out. Yeah, literally. And wild animals, it could have been, could have been anything.
Yeah, I mean, the source was never, I don't know that the source was never
It was.
specifically pinpointed to one thing. But there were opportunities for animal waste and pathways potentially for it to get into the water supply. So the purpose, the reason we're talking about all this is there is a motivation to reactivate well number 3. The low total coliform, no E. coli, correcting for that would be to condition that well water. There's also some concern.
Let me back up
Sure.
a little bit, because we get into this discussion all the time. On E. coli, the state says you can't have any E. coli in that well regardless of whether you condition the water or not. Is that correct or not?
No, if we treat this through the system that you have,
Yeah.
with the disinfectant and the contact time, you'll kill it.
Right. But the state, well, my understanding is the state won't allow you to do that. You must demonstrate that the well produces water that's free of E. coli, period.
Again,
Is that true or not true?
well, my understanding is if you treat it the source, you're going to take care of that. And
Well, I understand that treating it would take care of it. There's no question about that. But I was led to believe that the state would not accept that. Treatment was not an option.
Well, the treatment is an option if you have an operating permitted well, if you have the contact time. In our case, what they've told us is we can't reconnect well 3 until we were E. coli free.
Right.
Which in-house, we have been E. coli free now for several months. Okay? We'd still have to have it tested by a lab, but we don't anticipate that there's going to be any problem to that. That was something that we had to meet. That was a condition that we had to meet before we reconnected well 3. If we were to find, what I hear you saying, if we find E. coli in it once it's reconnected and working properly, that the contact time, the log 4 removal, will treat the
you'll
E.
still,
coli.
yes,
You still have to
and Bill brings up
monitor.
a good point. You still have to find the source of
That's
it.
right.
You
That's
can't
what
just say, oh,
people
now
say.
we have E. coli, but we have treatment, we're fine. But the challenge with well 3 in the past was it was pumped into this little well building 1 with just some chlorine addition, and then it was brought right into the distribution system. So there was never any contact time.
Well, my understanding of the distribution system was those tanks were installed on Snow's Mountain to serve as the place where the water would sit for a period and would be acted on by the chlorine. Is that true or not true?
No, it's not true.
It's not true.
No, let me see if I can, let me go back. And I'll show you why, Bill. I gotta go back to the map, so. Okay. So, the way the system is plumbed, this is well 3. This is a transmission main which has been pressure tested and inspected on the inside. This is well building 1 where chlorine was added. As soon as it came out of well building 1, it hit the distribution system here. If there was a dedicated pipe that brought the water from well 2 and well 3, a dedicated line that went all the way up to the tanks, you're absolutely right. You would get, the water would never be used until it came out of the tanks. That's not the case. It ties into a distribution main that heads up, let's see, is this Stone Tower Lane here? And actually this map is a little outdated because we did put in a connection here with a water main. There are taps off of this main. This house here, this house here, this house here. There's taps off the mains over here as well. So that there's no guarantee. If everybody had their faucets shut off and nobody used water until the tanks were full and the well shut off, and then people used water, you would get that contact time. But that's not how the distribution system works. People use water all hours of the day. So this water that hits the main here, depending on demand, could go this way, could go this way, could go this way. But the taps for these homes and along here are too close to the source so that you don't get the contact time and it doesn't get up into the storage tanks first. Then there's no way to control that unless the town put a dedicated pipe up to the storage tanks. So to get that storage, the project we're going to talk about is to actually make a connection from this. This pipe is in excellent shape, so we want to use as much of that as possible to avoid adding new pipe, then come across the river and tie into the treatment building. Then you've got that contact time, regardless of what the demand is. And a lot of water systems, that tank replenishment does happen usually during low use periods. Where I live in Concord, they have 7 storage tanks and they purposely run all of their pumps to feed the storage tanks from about 11 at night till 5 in the morning to put as much water into the storage as possible. But here, usage could be very little. A lot of water could make it up to the tanks without being used. Mass school vacation week, a lot of water could get used before it ever gets to the tank. So it's a demand issue. But there is no dedicated pipe to get up to the tanks. The water main, from that map where I mentioned your wells 2, 3, and 4 are on the west side of the Mad River, and the tanks are on the east side. They're connected by this pipe that was buried in the riverbed years ago. So that pipe was, I'm guessing, was put in 1972 when well number 2 went in. It was concrete encased, and I can recall being up in the valley some years ago and not being able to find this concrete encasement in the riverbed. But with more intense storms, Tropical Storm Irene was one that actually almost took the bridge out and eroded a lot of the river bottom here. It has exposed this concrete encasement. The concrete is cracked. There's rebar exposed. And if you stand on either embankment and look along the pipeline, this is actually deflected downstream. So there's some concern about the condition of this pipe. Having been put in 1972, it's approaching 50 years old. It's now been exposed. So part of this project would look at, if we're going to get well 3 water up to the new building, the treatment building, we would want to put in a redundant crossing for your treated water, another pipe. So if this one ever fails, you have a backup to get your treated water from one side of the river to the other side of the river. Do you have a question?
Yeah, how do you support other storms coming in and disrupting the pipe if you put this new pipe in?
Yeah, good question. This pipe right now is about 25 feet downstream from the bridge. And I'm sure, I've walked that walkway many times on the bridge. I'm sure all of you have at one time or another. If you look upstream, the riverbed's fairly wide. And you look downstream, it's fairly wide. The bridge creates a choke point, right? So the water feeds into that, comes out at a much higher velocity and causes that scouring to happen. So what we've looked at is the width of the riverbed, how it widens out and flattens out. We would actually put that redundant pipe farther downstream where the bed is wider and flatter, the riverbed is, so that there's not so much energy. This energy for when that bridge, I think Jim, you and Mark had told me you were out there during that storm, and the bridge was vibrating. I don't know, Margaret, were you there too? But it creates this vortex through that narrow opening underneath the bridge, and the water just rushes through there at such a high velocity to cause that scour. But it doesn't take long for it to get downstream where it widens out, and that velocity diminishes, and that's what we try to avoid, is that high velocity. So the objective would be to go farther downstream and make that crossing downstream.
I mean, it seems now that we're beyond 100-year storms, that we're getting worse than that.
Yeah, what they used to call the 100-year storms about every 2 years now, right? Yeah. But I mean, that's part of trying to make your system more resilient, to anticipate these things so that you don't. If this line were to fail, I'm sure Jim and Rob would come up with a clever solution to put some hose across the bridge or something. There'd be some temporary measure that would help, but you'd still need to get another pipe in there eventually. So the thought was if we're going to be putting a pipe in to get well 3 water to the treatment building, we might as well put another pipe in at the same time to get the treatment water across. Bill?
The question, I assume if the riverbed is not our property, right? It belongs to either the Forest Service or someone else. Is there permits required in order to put a pipe in there?
Yes, absolutely. So the good news for the town is, though, the town has land on both sides of the river.
Yeah. Right.
So basically, it's a wetlands permit. We have a shoreline permit and a wetlands permit. And generally, for the river crossings, any work that I've been involved with river crossings, the restriction, I've never had one rejected. The restriction is to do the work during a low flow period. So typically, for New Hampshire, that would be maybe July, August timeframe. So you'd want to time the work out for that, at least for that crossing, to happen during that period. So right now the well 3 pipe comes up here. We want to go downstream, come across the river. At the same time we dig, and actually, Bill, that's a good point. If we're going to do the permitting for a trench, we might as well put 2 pipes in the same trench. So one pipe would bring well 3 water up to the treatment building. The redundant pipe would be able to carry water back across the river to tie into the main feed distribution to the storage tanks. So it's trying to build some resiliency into your system at the same time. That well 1 building, Margaret, you mentioned that was hit by lightning last year, so that fried all the electrical systems in there. That's not a viable well building anymore, so part of this project would be to just decommission the equipment that's in there. If funds are available, maybe even demo the building, but at least decommission the equipment.
That well's no good.
Well 1 was taken offline for many years ago, but then actually decommissioned 4 or 5 years ago. That was the original well, and it was a very low producing well. Over time, it actually started pulling iron and manganese into the system, which would have to be treated. And because it was such a low producer, once well 3 came on, I think when 2 and 3 were on, at some point well 1 was just not used unless it was an emergency. And then when well 4 came online, the town just stopped using well 1. And frankly, all the 3 wells that you have, well 2, well 3, well 4, the water quality is exceptional. Well 1 had a different different water quality to it. So even blending it was really degrading the water quality from the other three wells.
So in decommissioning that pump house, why have well 3 cross the river? Why not go up the other side, say we're already on the west side of it?
Let me go back to the map. Should have had the map over here.
Show your option.
I will.
Okay.
Yeah. But it's a good question. So right now, this pipe comes across here. We talked about maybe putting a pipe across the bridge, so we could tie into this well 3 pipe, bring it across the bridge over. We even talked about putting a redundant pipe for your treated water to come back across. We did a risk analysis, and the concern was if the bridge was close to being washed out once. If the bridge were ever to be washed out, that would take out your supply and your treated water. And that was the rationale to actually come farther downstream and do a crossing down here. If you were to keep this, one of the options we also looked at was, what if we were to just provide full treatment here, expand this building? We would have to put in another clear well tank, but then we're duplicating what the town already invested in over here. So the cost of running pipe here is a lot less than expanding this for full treatment.
What about running the line from 3?
Right up here?
Yes.
Yep, we looked at that alternative as well. And over time, this is the West Branch here. Over time, there's been, and with Tropical Storm Irene, there's been more erosion of this embankment here. And the concern here is if this ever, say we get 1 or 2 more storms like that, there's potential for this to erode completely and then just spill into the Mad River. And then it would expose this line here. The cost of running from here up to here with a new pipe is about twice the cost of cutting across and running up. So there was a cost issue as well. But this was kind of a risk and vulnerability aspect when we looked at this. I think Jim and Mark took me out to this area last year to show you could see some of the erosion. There's some trees that have kind of fallen toward the riverbed. So in looking at that, the investment to continue the pipe up here is subject to this risk here of being exposed later from the storm event. Does that answer the question? Okay. This is well building 2. I didn't quite capture the rivers right here. This actually was almost washed out during Tropical Storm Irene as well. There was an embankment upstream that collapsed into the river and pushed all the water over to the west side, the west bank, and actually came over the embankment. There was erosion around this building. The building fortunately stayed and didn't get washed out, but there was a lot of erosion around there. This building treatment has been added, conditioning for chlorine and for pH control has been added. That building dates back to 1972. A lot of corroded equipment, old, outdated equipment in there. Again, the thought is, if you have a contractor out to trench to make a pipe connection from 3 up to the new building, as well as a redundant pipe across the river, it's a short run to get from this building to the new treatment building with some more pipe, and just put everything into that new treatment building. So all the water goes through the same conditioning and the same contact time. This is a well 3. I think this is probably an older picture before all the rehab work was done. So that's the well that's down on the peninsula.
If well number 2 right now doesn't have adequate contact time, why is the state letting us operate?
That's a good question.
Yeah.
I don't think
Because we
anybody's-
haven't had an
I don't think
E.
anybody's-
coli. We haven't had an E. coli yet, Bill,
Right.
and that's why they've noted it on they do an inspection every several years, and it's been noted that they want us to have more contact time, they want that log 4 removal, but it has been just a recommendation to this point, it's not been a requirement, because there's no bacteria. I would say that the same thing happened with well 3, that they will shut us down and we won't be able to connect back in the way that we're currently treated.
Yeah, but one of the concerns that I would have, if you connect two into the new treatment facility, you've got everything now in one centralized building. So if anything happens in that facility, you've got no water, right?
I suppose, the building was designed to be above the flood elevation. It was designed to take all 3 wells. The challenge with the redundant systems is you're not getting the same level of treatment or conditioning by having multiple systems. I suppose if a lightning strike hit that building, that would be an issue as well, but that's a random event.
Still have the tanks.
Well,
some point in
that's
time.
only a couple of days,
Yeah,
right.
given
Right.
whatever the daily demand
When-
is.
I mean,
at that
It'll
time.
happen on Christmas
I
week.
guess that's the doomsday scenario, Bill, if
Right.
something happens to that one building.
Right.
But the thought is there won't be any water mains or any piping coming through well building 1, so decommissioning that is reasonable. Well building 2 would just be rehabilitated. As I mentioned, there's a lot of rusty old equipment in there that just needs to be removed. I suppose in an emergency, we would leave taps in the lines there, so in an emergency, Jim and Robbie could put some chlorine back into that system and some pH control back into that system if needed for redundancy. But there hasn't been, in my opinion, based on if you did a calculation on the amount of time that water's in the transmission main, it probably isn't being adequately treated. So the recommended project was, we talked about well 3 being down here on the peninsula. There was a good question about running a pipe up here, but this is thought to be more vulnerable to future storm events. And because this pipe was pressure tested and inspected and found to be in excellent condition, the thought was to save the money of putting a brand new line in, either crossing here or up here, and just tap into this line. About 100 feet downstream from the bridge, where I mentioned before the river's a little bit wider, a little bit flatter profile. Even any high velocity water that comes through the bridge tends to dissipate as it gets downstream and everything widens out. So the thought is to tap that well 3 line and bring a line up to the new treatment building, and at the same time put in some valves and T's where the treated water now comes down in this pipe and crosses that crossing we saw in the riverbed. Put in T's and valves and run a secondary line down and tie it back in. So if the bridge ever washed out, there would be a way to still get treated water to the storage tanks and the distribution system. And I mentioned demo pump house 1. Again, if the funds are there, if nothing else, the equipment would be removed. If the funds were there to just take the building down and level out that site, that could be done as well. Well building 1 is officially abandoned. There's no more permit. Well for well 1, so that will never be used again for drinking water. And this treatment plant building here was designed, I don't know if anybody has, I know you've been in it, Bill, you've probably been in the treatment building. Has anybody else been in the treatment building? You have. So there's a pipe gallery down below that was designed to take pipes from wells 2 and 3 in the future. So it was set up, it was designed to handle all of that. So there'd be some site work involved to make those pipe connections.
So is one of the options, that you could look at, which is basically, I understand that if you're going to go to the trouble of putting a trench into the stream, you might as well put an extra pipe in, but not connect it. Until it turns out that the main one across the bridge is gone.
Yeah, I think our recommendation would be to put in the T's and valves and have it ready, Bill, and not necessarily use it.
Right.
But that way, if that did happen, if the bridge washed out, or if there's just a big storm event that causes some boulders to tumble down and finally breaks that concrete and releases the pipe joint, then it's a matter of the crew going out and opening and closing some valves so maybe you lose the supply connection and the treated water connection for a period of hours. But if we just put the pipe in across the river and left trenching and pipe and fittings and everything to be installed, that would be days, I think. Even in an emergency, it'd probably be days to get that.
Following that same reasoning, if the second pipe is really a contingency, why couldn't you just run that across the bridge and not hook it up?
Yep, that's good.
And only use it if you've got an emergency.
Yeah, it's a good question. And again, we did I'll go back to the comment earlier about the 100-year storm seems to not be every 100 years anymore. We did kind of a risk analysis on that and actually thought about putting a bigger pipe on the bridge that could actually be a two-way pipe. It could be initially served to get well 3 water over for treatment and continue to rely on this. And then if this fails, it becomes a treated water pipe and you just don't use well 3 anymore. So we looked at that scenario. We looked at a handful of scenarios here of what you pointed out earlier, the new main in that peninsula, in that land the town owns. There's exposure, we think, in the next, could be the next 10 or 15 years to that being washed out. Anything on the bridge also became that risk scenario of what happens if the bridge washes out. Right now there are several utilities that cross the bridge. The low pressure sewer force main crosses the bridge. There's electric, phone, cable. There's a lot of utilities strung under that bridge now. If we put water pipes on that and that bridge ever failed, you would lose all of that as well. So that, looking at that scenario, the cost of hanging the pipe on the bridge, which would be probably reinforcing some beams, it's a lower cost capital cost, but it's a higher risk long term than just burying the pipe in the riverbed. So we tried to weigh, today's cost versus the resiliency and the really decrease the risk as much as we could. And that crossing the river is really the lowest risk of any of these scenarios. And again, it's about your system has served the community well for almost 50 years, and the thought is to try to make these last improvements between the connection between supply and distribution and treatment so that will last you another 30, 40, 50 years. And again, in looking at, Bill, you mentioned the permitting. That's probably about 20% of this cost right here is dealing with the agencies and getting all the permitting to do the river crossing. But again, that's the lowest risk scenario of all the scenarios we looked at. This construction cost includes all the pipe connections, decommissioning equipment in well building 1, connecting wells 3 and 2 into the new treatment system. In doing that too, there'll be some communications equipment that gets put into the new well building, the treatment building, that's not in there now because those 2 wells will now be connected to that building. Any site work, the redundant line, treated line, that's all on that construction number there. This contingency, we generally carry for at this level, the conceptual level where we're kind of sketching things out, we generally carry about a 10% contingency because there may be things that come up in design and back and forth with the agencies that that will eat into that. And then the engineering, as I mentioned, about 20% of this has to do with all the permitting that has to be done. And then there's design of all the different pipes and demo and improvements and connections. And then the construction services, we put this number in there depending on how the town funds this. If they want Boyle Tanner or another firm to be checking in on the project daily, there's more cost to that versus checking in on once a week. Funding agencies, depending on the town, we have investigated, we are exploring some funding options, trying to get some grant money for the project. Some of the funding agents require an engineer to be there full time. So this number reflects that, it may be less. And that total project cost adds up to a $1 million project. And really the rationale, and there's pros and cons to all of these scenarios, there's risks with all of these scenarios. Even burying the pipe in the river is not 100% risk-free. If we get the mother of all storms, 40 days, 40 nights of rain, all bets are off. But really getting well 3 back into the system gives the town a redundancy in supply if one of the other wells goes out. And during a low use period, not so much an issue. During a high use period like Christmas week or school vacation week, it becomes an issue. And then optimizing the treatment for all the wells. You've got excellent water quality, other than this E. coli hit that came about likely from deterioration of the original well construction for well 3. The water quality that the town has is exceptional. And putting it all through one treatment system to get the same type of treatment and conditioning, which I believe, you all can tell me it's probably been working pretty well since it was put in. Again, that's having a good clean water supply is a huge resource for the town. And thinking about that extra pipe, I think that resiliency is a good idea. You're going to trench across the river anyways. Let's put another pipe going the other way. And that's a low-cost move to gain some of that resiliency if that original pipe fails. And let's face it, that went in 1972 with well 2, so that's 48 years in the ground in the riverbed. It's not a question of if it will fail, it's just a question of when. Could last 5 years, could last another 10 or 15 or 20. But I think it's a good idea to do this now. And lower operating costs. The way the system had been run when well 3 was active was chemical conditioning in well 1, well building 1, chemical conditioning in well building 2, then when 4 was brought in, chemical conditioning again in the treatment building. Eliminating those extra chemical feed systems is just going to be lower cost for the operators, going to be less exposure, less time. Ultimately, it just improves the efficiency of the system. It's a building, your point earlier, it's a good idea to leave some taps in the lines in well building 2 if it's ever needed in an emergency, but not necessarily having to stock chemicals. Those chemicals destroyed the inside of that building and just ate away, corroded the inside of that well building 2. So I think that's we think it's a smart move to get this piece done. That pretty much secures your sources and your treatment and getting your treated water into your system. And, there may be other projects the town does over the next 10 or 15 or 20 years in the distribution system, but this kind of completes the source water and treatment portion.
Is the treatment equipment automatic? Is it run by, say, a computer?
Yep, I'll let these guys answer that.
The equipment in Wellhouse 4 is all flow-based. So water coming into the pump house decreases or increases, the pumps will automatically maintain according residual pH as what's
The question was to maintain the level of chlorine in the total water supply at a very constant level.
Yes, that's what Wellhouse 4 is set up like.
Which is very difficult to do in well building 2 right now because it's a manual system.
Right, that's what I was asking.
Right.
So if after this project is complete, the introduction of chlorine into the tank where it will sit for a while, that's all done automatically and
That makes it more efficient.
It is more wise, it's how today's systems are run. Well, the well 2 building, the manual chlorine addition was how it was done in 1972 and 75 and 1980. There's been, I was telling Mark earlier, I was trying to go back and look at, we did a little timeline of projects. I was thinking I might do a timeline of the regulations, but trying to find, they're amended so often, and you get all these references and just go back to different time periods, and digging all those amendments out is too cumbersome. But what was in well building 2 in 1972 was how it was done for wells, for groundwater supply. What's in this building now is how it's done today. So having an automated feed system and having devices that are checking that automatically as well, and these guys will get alerts if something's parameters are out of whack or something's not right. They get alarms. It's all radio controlled, and SCADA goes back to the wastewater plant. Or it goes to your phone, Rob. I don't know.
Unfortunately,
yeah. So you never get away from it. But that's how it's done today. It's more automated, more sophisticated, but it's intended to be
And what's the timeline?
For the project?
Yeah.
So if the project's voted in, one of the first things we'd have to do, Bill, is start working with the agencies on the permitting. So I would anticipate we'd probably use 2020 to line up, try to find any grant funding. There are some programs out there. We've got a couple of applications in now, and there's a meeting in April with DES on water and wastewater funding that we'll attend. We would work on the permitting, likely get the project designed this year, put it out to bid maybe at the end of this year or right after the 1st of January for construction next year.
This may be a foolish question, but why are we treating water at all? You know, if you have a personal well, you don't treat water. Why would you
Right.
treat it?
So it's a good question. In a public water system, you have to provide insurance that there's not going to be any bacteria in the water. There's no control once the water leaves the well. There's no control over how long that water stays in the system. Waterville Valley being a resort community, there are probably periods of time where homes are just buttoned up and people aren't here and the water use is low. So bacteria can regrow in the distribution system. So a modest amount of chlorine or any type of disinfectant is required by law, by rule, by EPA and DES to have some modest amounts that you don't have bacteria regrowing in the system. The water, generally out of well 4 and well 2, is really, really clean. If you could ensure that it stays that way until it gets to your tap, it may not need it, but by rule, it has to have some sort of a minor amount of disinfectant to make sure that the bacteria doesn't regrow in the distribution system.
So we're just putting chlorine in the event of bacteria.
Absolutely. And you could have a leak in the system. There could be a bad connection in the system that under pressure it pulls groundwater into the system. The distribution systems aren't 100% tight. And there are avenues for contaminants to get into the distribution system. So a modest amount of disinfectant just keeps that from being a problem. Yeah.
But it's only a matter of time before the current pipe across the river deteriorates. At that point, do we abandon that pipe, or is that going to have to get replaced?
I'd say it's probably best to just abandon it. And that's why we would probably put in some fittings and valves so that when that happens, it's just shut off. So no water flows through it anymore. And if, this is something we have talked about, different ideas. Again, if we're going to trench across the river, maybe we put 2 extra pipes. And as Bill suggested, just leave one dead-ended, but connect the other one.
Yeah, that way we don't have to dig in the river again.
Right. But that location is not a great location now. I would think probably 50 years ago.
The existing pipe.
The existing pipe. Yeah. The storm events that we're having now, there's boulders that used to be upstream of the bridge, they're downstream of the bridge now. Right. So I think that location would not be a great location to restore that.
It's a miracle that the bridge survived.
Yeah.
I didn't see it. I wish somebody had. When the bridge was quaking, it was that close.
You could hear the rocks rolling down the river.
Yeah.
I mean, it was that bad.
Well, you think about just look upstream at how much wider the riverbed is.
Oh, yeah.
And having to come through that throat just creates all this velocity through there too. It was probably a fine location and it was easy to do in the 70s when that was put in.
Because the bridge helped.
But we got to look ahead at what might be coming for storm events in the future.
I wanted to ask you about the abandonment of well number 1. That's already been abandoned, right?
Yes, it's been disconnected.
What has been done to that site to make sure it's not a safety hazard? There's not an uncapped shaft. There's not a shaft that anybody could.
No.
All right.
No. It's a big concrete.
It looks
cover.
just like well 3.
Looks just like well 3.
Okay.
And there's no way you can move it or.
All right.
Well,
So
I guess.
it looks
just like that.
looks just like that.
That's a good question. And decommissioning wells too, there's usually cut off the connections and have to seal the wells. I wasn't part of that necessarily, but
There's a blank flange there.
blind flames there, so there's no way that can
There's no way.
accidentally get into the Question?
That wonderful pipe that's running in the river now.
Right here?
Is there anything that can be done to support that until the new system is up and running in case we have another major storm?
Yeah.
I mean, what's happening to that in the interim?
Yeah.
Yeah, we don't have any money in this project, and I think we don't want to touch it because it might fall apart, it might crumble in our hands, so I think.
It's a good question, as I mentioned earlier. I mean, I'm sure if that did fail, I'm sure these guys would find a way to tap the lines on either side and put a temporary line in. If the bridge didn't go downstream, the obvious choice would be
Bridges did though.
no, well, the obvious choice would be to hang something off the bridge temporarily. But yeah, it's just, you know, the rebar is exposed here, this is cracked.
It's scary.
And laterally, this joint right here now is farther downstream than the two ends at the embankment. You can stand at one embankment and see how it's deflected downstream. I mean, I don't know, we haven't found any design plans to see exactly how this was done. So I don't know if this concrete is 12 inches deep or 24 inches deep or, you know.
And with our luck, that break is probably right on a pipe joint.
Actually, it would be likely that would be a weak point, right? So that could be interesting once the new connections into, I don't know, maybe put some more material. The challenge too is, if you look at this, I think probably, Jim, you could go back even 10 years, and I think you could see maybe a little bit of this concrete over here.
Right.
Yeah.
This was all rock.
Yeah.
This whole area was all stone and rock bed.
I know.
And this boulder, I understand, used to be upstream of the bridge, but it's now downstream from.
The new crossing point will be how far downstream from that? 100 feet or?
This is about 25 feet downstream of the bridge.
I know, but
we'd go about another.
the new crossing?
We'd go about another 75 feet downstream. Unfortunately, I didn't take the picture. I should have found a picture that looked more downstream. But right after this bridge opening, there's some heavy rock and riprap fill on both sides, and then this actually widens out a bit here, and this widens out a bit, and it's much flatter. The whole width of it is pretty flat, so the energy dissipates down in this area. Question?
So with success with this project, and I'm assuming that we'll get the state to say we're COLI free and get 3 up and going, is the biggest risk, and then you'll have capacity for like 600,000 gallons per day between the 3 wells?
You'll have the potential for that. And right now, in that new well building, there's 2 pumps. Only one runs at a time, and each pump can pump 500,000 gallons.
That's where I was going.
Yep.
Because now you're going to decommission a pump house and down to 1.
Yep.
We have capacity, we have redundancy, we put that into the new treatment building when we built it.
So you do have
Yeah,
pump capacity.
there's 2 pumps in there.
Okay.
It's a good question. There's 2 pumps, but they're not designed to run together. They can alternate. So if one pump fails, you always have a backup.
So you got redundancy.
Right. Yep. Good question. Bill?
Yeah, I think, I would, if I were gonna do this, I think I would take a look at putting a piece of conduit into that riverbed so that you could replace the electrical, the sewer lines and everything else.
Sleeve.
Yeah, something
Yep.
that
Get it off the bridge.
potentially you
Yeah,
could snake
maybe
everything
4 pipes.
through.
Yep.
Without having to recommit that thing.
Just do it.
Because sooner or later, that bridge is gonna get killed.
Yeah. No, that's actually a good point. We kicked that around in discussion. Would we want to dig down maybe a little deeper, a little wider, and put a larger sleeve, maybe like a 3-foot or 4-foot diameter sleeve that you could fit any number of, we could put empty conduit in, we could put, 2 6-inch pipes in, we could put an 8-inch pipe for well 3, and then maybe, as you described earlier, maybe just not connect most of that, just
Right,
block
I
it
would
off.
connect it all.
But make the connections that would provide the resiliency. That's a good suggestion, and that's actually one of the discussions we'll have with the permitting agencies, is if there's any limitation on disturbance. They generally look at square foot of disturbance. We would want to look at how big could we do it? Could we stack things? Could we maybe put things vertically, one over the other, rather than
Yeah, because the
Spread 'em all
electrical can be closer to the surface.
Electrical could be,
Yeah.
and would we want a concrete encase versus just backfilling it? Maybe put in a structural fill or a flowable fill to give it some stiffness. We would definitely want it deeper than this, and we would want to put whatever material we took out of the riverbed, we want to spread back in, so it's the natural material.
So I have a question for the selectmen, right, which is, if we're not gonna physically construct this until next year, why don't we split this appropriation and fund what we need to fund now for the engineering design work and the permitting and all of this? And next year, we'll come back and fund the rest of the project.
Well, I think, Bill, if we, just off the top of my head, which is where it's coming from, I think it's because we want to apply for grants and bonds for the whole project.
Right, well, why would that prevent you from doing it? Maybe you don't need all this money.
Well, you need the appropriation approved. If we appropriate $1 million, doesn't mean we need to spend $1 million. If we can do it another way, or something comes up that saves us money, and we only spend $850,000, that's what we will bond. You're just giving a maximum bond authority, and so we have a cost estimate for the project, and it came out to $1 million. So that is the maximum authority to do the work. But the funding agencies will be basing their decisions on our authority, the maximum that we can set.
It's a good question, Bill. It's a legitimate question, and if you recall, the other improvements were funded through a USDA allocation, right? So the town was able to get about $1.5 million in grant money for that. If that had been pieced out, each year at town meeting, you would have to vote and approve the next piece.
Yeah.
And you'd be limited to doing that piece. Because they're only going to fund what the voters say they want to fund. So if the voters said, all right, well, let's just fund $125,000 now and get the permitting and engineering done, we could put in an application and hopefully get some grant money to offset that. But then you'd be back at town meeting, and we couldn't get any funding until after the town
But
meeting.
you have a better estimate of what it's really gonna cost, because my fear is that you're gonna get down the road and then you're gonna find out you need another $250,000. And, so you'll have to come back next year anyway and ask for supplemental funds, to add on to this.
Yeah, I think that's, for this type, or more of a pipe project, I think that's less likely. No, I really do. It is more pipe and fittings, and yes, we have to make some adjustments in the new well building to bring in those controls for the different wells, but it's more straightforward than what was done before.
For the new well.
The new well in the 4.5-year permitting process with the Forest Service was an exercise. It was challenging.
Who knows? As soon as I hear governmental permits, it's like, forget about it. Who knows what time it's gonna take to get those permits.
And frankly, that's why we're saying get the design and permitting done this year in construction. We could be shocked to get permits much faster and maybe get this out to bid sooner than later. But I think that's the conservative take, is to say we would. I think the permitting is probably going to take 3 to 6 months, just based on past experience. So, and the funding too. The other tricky thing is there's the town. I'm sure all of you selectmen are wrangling with all the different demands. For every dollar you have, there's $10 demand for every dollar you have put toward community projects, and the competition for the funds. There's an ebb and flow sometimes. But there's a lot of competition for the grant funds and the different funding programs. The low interest loan rates right now, I think the recent USDA rates are around 1.6% financing. DES has some loan forgiveness programs with their low interest loans.
And there's no pre-penalty payment, so prepayment penalty, so we could accelerate the.
And there's the Drinking Water Groundwater Trust Fund that is helping to fund community projects. So there's a lot of stones we still want to turn over on the funding side. If we did that for the engineering, we'd have to do it There's pros and cons to both of them.
Any other questions of Joe on this project?
Mark, we can make sure you have a copy of this PDF, and if you want to put it, make it accessible on the town's
Yeah,
website.
we will, we'll PDF.
And if any questions come back that
Yeah.
need to be answered, I'd be happy to do that as well.
Can I ask a silly question? When you go and put this new pipe in, based upon, do you have any idea about the depth that that pipe was put in?
I really, that's why I said, I don't
You
know
don't
how
know.
that was put in, I don't
So,
haven't seen plans for
From a
that.
standpoint of
Yep.
storm and erosion and whatnot,
Yep.
is there, are you dictated by the state about the depth of a pipe?
We would typically, for any, what I would call a cross-country pipe, where it's not under roadway, we would typically go 5 feet from the top of the pipe to the ground. So we would typically go pretty deep to begin with. My guess is if the whole 5 foot of the street bed was stripped out, there's so many other issues in town that the water supply is probably not even considered at that point.
There are no buildings.
But typically we go 5 feet
Okay.
below
I was
natural
just
ground, we
wondering
go
that.
6 feet
Yeah.
below pavement,
Uh-huh.
and we actually, in the valley, we learned we go about 8 feet. Because there's some areas.
1970, they probably didn't need permits, right?
Yeah, here they probably just.
They
did
probably just
3 or 4.
said, we're gonna put a pipe in
Pipe
across.
it, right.
Oh, okay, let us know when it's done, you know, or maybe we'll come up and look at it. It's changed, I mean, it's more challenging to do, but, that's a good question. Our standard would be 5 feet minimum.
Thanks.
Thank you, Joe.
Okay?
Thanks, Joe.
Good, thanks, everybody.
Thank you.
Thanks, always, Matt.